Asked a random sample of U.S. adults, do you support a 2-week waiting period for those who wish to purchase a gun? Of 528 males in the survey, 285 of them said yes, and 224 or 475 females said yes. Okay, so the two different groups we have here are males and females. Okay, so those are the two independent groups. And there are more than 10 successes and failures in each group. Okay, so we have the conditions checked off where we can actually compare the difference in proportions. Okay, so part A wants us to construct a 95% confidence interval for the difference in proportions. So that's, again, P1 minus P2. Okay, if you're reading this and if you're reading a question and it said construct a 95% confidence interval for the difference in means, well, then you're back to mu1 minus mu2. Okay, and that's a different problem. Okay, but here the difference in proportions, we're on this topic now. Okay, P1 minus P2. Okay, so I'll just identify the males as being the first proportion and P2, the females, as being the second proportion. Okay, so when we go through this problem, okay, we're looking at constructing a 95% confidence interval. So that, again, that's your P hat 1 minus P hat 2. Well, the number of males who said yes, 285 out of 528. Females, 224 out of 475. Okay, and again, I have this all written out just for the sake of time. Okay, I'm just going to put this up here. Okay, so we have P hat 1 minus P hat 2. And then plus or minus the Z star, so a 95% confidence interval, that your Z star value is always 1.96. And then the 285 out of 528, okay, that's your P hat 1. Q hat 1 is the complement of that, so you take 528 minus 285, and that gives you the 243 out of 528, divided by N1, 528. And then similar for the second sample for the females. 224 successes or yeses out of 475. And then take 475 minus 224. That'll give you the 251. Okay, that's the complement of the successes, yes. Okay, and then you're going to put that in your calculator. And again, I highly suggest you do this because it's easy to make mistakes on this. A lot of students just punch in the wrong digits or forget a digit. Okay, just silly little things that you mess up. So make sure you can do this. And when you do that, again, I don't need to see this step, but when you take the square root of all this inside the square root, you get 0.03154527. Multiply that by 1.96, and that'll give you a margin of error of 0.06183. And this is kind of a bad example because of the 6s, 1s, and 8s in there. It's easy to get a little I crossed in there, or cross-eyed. Okay, with the margin of error there is about 0.06183. Add and subtract that from your 0.06819, and there's your confidence interval. Okay, so we're 95% confident that our interval contains the true value, the population difference in the proportions of males and females who said yes. And in terms of just using P1 minus P2, that's how you write your interval. Okay, here, the fact that both of those intervals, the entire interval just has positive numbers in it. Well, P1 minus P2, remember P1 is the percentage of males. So it looks like the percentage of males minus the percentage of females gave you positive 0.06819. Those are from the samples. So the fact that both of these values are positive, the endpoints of your interval are positive, okay, what that's supporting is the idea that the males, the proportion of males is higher than the proportion of females. And again, if 0 were included in this interval, so suppose that was negative 0.00636, okay, then, and this was still positive 0.1300, so this was negative and this was positive, okay, then 0 would be in the interval, which would indicate no difference in the difference in the proportions of males and females who said yes. But the fact that they're both positive, in this case, tells you that P1 was greater than P2. Okay, so the males, it looks like, was higher proportion than the females. And that's really answering part B. So So the interval supports that the proportion of males who said yes is higher than the proportion of females because the interval has all positive values. Okay, part C, we're going to test the claim there's no difference in the proportion of males and females who responded yes. Okay, we're going to use an alpha's 0.05 level of significance. Okay, so now we're going to kind of start over and look at a claim, testing a claim, so this hypothesis test. Okay, so again, I'm just going to go through this very quickly. You write your hypotheses, HO and HA, so your null and alternative hypotheses. And your null hypothesis is always that they're equal to each other. And in this case, the claim is there's no difference, so that means their claim is HO. Okay, so this is the case where the claim is HO. A lot of students get confused because they think the claim is always HA. It doesn't have to be. Okay, it depends on the wording of the question. Okay, so HO is that P1 equals P2, so the men and women have equal proportions, and that is our claim. The alternative will be not equal to. Okay, so P1 does not equal P2. Okay, you find your test statistic, your P hat 1 minus P hat 2. Okay, and that's the same thing as the confidence interval, divided by your P hat Q hat times 1 over N1 plus 1 over N2. So here, there were 509 total people that said yes out of 1,003 total people. The complement of that would be 494 out of 1,003. So those were the total number of people that said no, or not yes, out of 1,003. And then there's 528 in the first sample, 475 in the second sample. Do all that arithmetic in your calculator, and we end up with a z-score of about 2.16. Okay, so now, if your z-score is 2.16, now if you look at for the p-value, well here, the not equal to in the alternative hypothesis, that's how you identify that you could be on either side of the center here. Okay, so the not equals to means we could be over here or over here. So that's where the alpha over 2 equals 0.0250 comes from. And again, this is why I keep saying that the concept is the same. The not equal to in the alternative hypothesis always has the two-sided hypothesis test, or two tails here, where you do alpha over 2. Okay, no matter what you're testing, if that's a not equals to in the alternative, the chart or the diagram set up the same way. Okay, you do alpha over 2, back on each side. Okay, so we have 0.0250, because that's 0.05 divided by 2. And when you take your z-value of 2.16, we can see we're on the right-hand side over here. Well, when you look at the p-value, you want to find the probability of getting a value as extreme or more extreme than 2.16. Okay, so 2.16, you're looking at higher than 2.16 here. Okay, so that p-value is 0.0154. Now you can also look at this as keeping alpha as 0.05 and multiplying this number by 2 to get about 0.308. I think that's what it would be, 0.038. I'm sorry, 0.0308. Okay, about 30%. I'm sorry, about 3%. Keep saying the wrong number. Okay, about 3% if you double that. Okay, so rather than take alpha over 2, some people look at it as doubling this value. Okay, the p-value I have here. But still, the 0.03 is less than 0.05, just like 0.015 is less than 0.025. Okay, so in any event, what that tells us is that our test statistic of 2.16 was more extreme than what we were willing to accept. And by the way, the positive and negative 1.96, those will be the cutoff points for the z-scores. If you look up a value of 0.0250, okay, in your table, you'll see 1.96 for the z-score. We can see that 2.16 will be more extreme than that. Okay, so what that tells us is we reject HO, and this is a case where you have to pay attention to the claim. We rejected HO, so that means we're going to reject the claim. Okay, so there's enough evidence to reject the claim that there's no difference in the proportion of males and females who responded yes. Okay, so rejecting the claim that there's no difference in the proportions, which is supported by part B above in the confidence interval. Okay, now you have to pay attention to how big the confidence level and the alpha down here. Okay, you can't just assume that you get the same answer each time. Depends if those values end up being different areas in the curve. Okay, but up here we did say that it does appear the proportion of men were higher. And down here, we're basically saying not the same thing, but we're saying there's no. We're rejecting the idea that there's no difference. So we are saying that there is a difference in the proportion of males and females. Okay, so that's the video for comparing two proportions. Okay, just need to practice some of them, and the formula looks really crazy, but it's just a matter of picking out the correct information in the problem. Okay, and again, in a future video, we'll look at using the calculator and how to do confidence intervals and hypothesis tests using the technology.